Hi everyone, in this video we will discuss the problem sum of nodes on the longest path from the root to leaf. So in this problem, we'll be given a binary tree which will be having total n nodes, and we have to find the sum of all the nodes on the longest path from the root to any leaf. If two or more paths are longest, then we will consider that path which has maximum sum. So let us see both the test cases that have been given to us, then the problem statement will be more clear. So here in this case, if you will see the first test case, so suppose that we have 4, then we have 2, then 5, and after this we have got 7, then we have got what, then we have got 1, and then we have got 2, and then we have got for 5 we have got 3 as well, and then after that for 1 we have got the left child as 6. Suppose this is the tree that has been given to us. Now in this particular tree you can clearly observe that what is the longest path here. So if you start from 4, okay, so if you start from 4, from 4 you go to 2, then you go to 1, then you go to 6. So 4 plus 2 plus 1 plus 6, this is the longest path. How we can determine that? So basically you can see that if the level here, if assuming that you start the level from 1, so here the level will be 1, next time the level will be 2, next time the level will be 3, and next time the level will be 4. So the longest path will be basically at the deepest level. So you can see that this will be the path 4, 2, 1 and 6. Now if you take the sum of all these elements, so it is going to be 6 plus 6 plus 1, that is going to be 13 here. So you can clearly see that the answer for this particular test case is 13, because there was only one longest path, so whatever sum it had, we'll consider that. Now if you had to solve it, how you would have solved it? Basically by going on the left. If you are at a particular node, so you will add its value inside your sum, and then whenever you go to the left, so then you will increase the level by 1. Whenever you go to the right also, then you will increase the level by 1, because if you go to the left child or the right child, the level will increase by 1 always. Okay, and whenever and you will also keep a track of the maximum level. If the current level becomes greater than the maximum level so far, then you will update your sum. Okay, or suppose if the current level is equal to the maximum level, then this means that we already had a maximum level, and again we have again reached a path which is having the same length as the longest path. Then we will check if the sum of the current path is greater, then we'll update according to that. So if you will see the next test case, so we have got 1, 2. Okay, let us say that we have got 1, then we have got 2, then we have got what, then we have got 3, then after this we have got 4, then after this we have got 5. Okay, and then we have got 6 and 7. So if we have got this particular thing here, so what we will be doing here is, first of all, when we'll start off, so initially we'll mark our maximum as what, let's say since the nodes can be positive only, so that is why we can initially mark the maximum as 0, and we can mark the maximum level also as 0. Then what we will do is we'll keep a track of the sum. Okay, so when we are here, so we'll take the sum as 1, then after that we'll go to the left child, so we'll go to 2. Okay, so here the level is 1. Since this level is greater than the maximum level, so we'll update the maximum with 1, and the sum is also greater, so we'll update the sum with 1. Then after that we go to this element 2. Here the level will increase to 2. Okay, and this level is greater than the maximum length, so we'll update the maximum as 2, and the sum so far will be nothing but 3, so we'll update the sum as 3, because we'll keep a variable sum with us. Then after this again we'll go to from here we'll call for the left child. When we call it, so the level will become what, the level will be 3. Basically the length of the path will so far become 3, and now I'll add this particular node as well in my answer. So 1 plus 2 was already there, plus 4, so the sum will become 7. So now the maximum length is 3 and the sum is nothing but 7 here. Okay, now after this what will happen here is, then from 4 we do not have a left child, so we'll not call for the left. We do not have a right child, so we'll not call for the right. Then after this, when we move back from 4, then from 2 we'll explore the right path. So when we go to right, then 1, 2, 5. So this, like you can see, the length here will be 3 for this particular path, because the level will be 3, and the sum of this particular path, so the length is same as the maximum length that we have stored so far. Okay, and what is the sum of this particular path? The sum is 1 plus 2 plus 5, which is nothing but 8. So we'll update the maximum with the value as 8. Okay, then after this what we will do here is, then we will then for 5 we do not have a left or right child, so we will move back from here. Then for 2 we have followed both left and right, so we'll move back from here. Then the moment we reach 1, so from here the right call was pending, so we'll make the call on the right. Here the level will be 2. Okay, then from 3 we will go to the left. When we go on the left, so we go to 6. Now level is 3 and it is a leaf node, So 1, 3, and then 6. So 1 plus 3 plus 6, and this length is 3, which is equal to the maximum length. So we will check that if two or more paths have the same maximum length, then we will consider the path which is having the maximum sum. So this current path that I have traversed, 1 plus 3 plus 6, its sum is how much? Its sum is basically 10. So it is greater. So we'll update the maximum with the value as 10. Then from 6 we cannot go to the left or right, so we'll go back. Then from 3 we can call for the right also, so we'll call for the right. Here the level will be 3, so again it is a leaf node. So now since it is a leaf node, so I'll check, is the level equal to the maximum level or the maximum length of the path? Yes. So then we will do what? Then we'll say that the sum of this path is 1 plus 3 plus 7, which is 11. So it is greater than our maximum. Okay, so we'll update the maximum sum with 11 here. And if you will see the answer for this particular test case, so you can see that the answer for the second test case is 11, because there were total 4 paths which were the longest path. Okay, and out of that, the this particular last path that we were at, it had the maximum sum. So whenever we have multiple paths with the maximum length, then we will consider that path which is having the maximum sum. So this is how we can apply this logic in the question. Now talking about the time complexity of our approach. So time complexity will be how much? In the worst case, the tree can be skewed either in the left direction or in the right direction. All the nodes are either lying in the left direction or every node is lying in the right direction. So in the worst case, the time complexity would be order of n, and space complexity would also be order of n in the worst case, because I am going to use the recursive approach to implement. So in the worst case, the recursive stack space will have n nodes inside it. Now coming to the implementation of this particular question. So what we will be doing here is, first of all, we will declare several variables. And what are those variables? So firstly, we need to store the answer. So initially we can mark our answer as what? Let's say we can mark it as int min, although we could have marked it as 0 also, but I'm initially marking it as int min, and I'm marking the maximum level as suppose 0, right? Let's say I'll also declare a variable int max level. Initially I'm marking the max level as 0. Then after this, what we will do is we'll start with our recursive function. So, or you can say that we will start with our DFS function. Now what we will do is we'll start from the root node of the given tree. Okay, and then initially we will say that our level will be 1 and the current sum will be nothing but 0. And at the end of the day, we will return what? We will return the answer, that is nothing but the maximum sum. So let, instead of answer, let us declare the variable as maximum sum, so that things are more clear to all of us. So we'll declare this as maximum sum here. Okay, now when we will be running this function, so first of all we'll write void dfs here, and then we will pass the root node, so node star root, and then after that we will also pass what? We'll also pass the level, so we'll pass int level here. Now after this particular thing is done, then we will also pass the current sum of this particular path. Okay, now when we are passing these variables, so we will check that suppose if we reach a particular node which is null. So if we reach a particular node which is null, then this means that we cannot go anywhere from there. So we'll return simply from there. Okay, otherwise what we will check is, in our current sum we will take the if the current node does exist, then what we will do is, in the current sum we will add the value of the root data. Okay, then after this we will check that if the current level that is there. Okay, so let us mark this variable as current level. Okay, so if the current level that we are at, if it is greater than the maximum level, so this means that if the current level is greater than the maximum level, then we need to say that the maximum sum will be nothing but the sum of this level, because since we found a path from root to leaf which is having higher length, longer length, so then we'll directly update the sum of that. Otherwise another scenario can be that, suppose else if the current level is equal to the maximum level only. So if we see a path which is having same length as the maximum length that we have found so far, then in that case we will check. What we will check is that if the current sum that we have, if it is greater than the maximum sum, then only we will update the maximum sum with the current sum. Because if there are two or more paths which have the same longest length from root to leaf, then we'll consider that path which is having the maximum sum. And once this is done, right, so then after this what we will do is we'll call our dfs function for what? We'll call our dfs function for the root current root left child. Okay, and then we'll mark the current level as current level plus 1 for the next call, and then we'll pass the current sum variable as well, which is obviously updated with the sum. right? And then after that we will also do what we'll call the DFS, that is the recursive call in the right no of the root. So we'll call for the current's right child, and then the level will be nothing but the level of the current node plus 1, and then we'll pass the current sum as well. Okay, now once this has been done, so let's try and compile this code to check if it is working fine on the samples or not. So there is some mistake that I have done. It says that sum was not declared. Okay, because I have used current sum, so let's use current sum here, and that would do our job. Let's now try to compile it again to check if it is working fine or not. So it is not giving me the correct answer for some reason. Let us quickly check. So yes, basically if it is giving me the answer as 12 for this particular test case. So initially what I've done is I have passed 1 here, and then I have passed the sum current sum as 0. Then after that I have returned the maximum sum. So initially we have initialized the maximum sum as nothing but negative infinity, and the maximum level, let's say, as 0. Then after that we have the root, and we have the current level as well as the current sum. Then if the root that we are at, if it is null, then we return. Otherwise we, in the current sum, we take the data of this root, and if the current level that we are at, if it is greater than the maximum level, okay, then what we will do is we'll update the maximum sum with the current sum, and then we'll update the maximum level also. So this is one part that I missed, that maximum level will also be updated to the current level. Okay, now let us try and run it again, because whenever I found a new path, the longer path, then I need to update that also. Okay, otherwise if I find another path with a maximum length, then I'll update, but I should have not done this. Okay, so yeah, it is getting accepted for all the 1120 test cases. So I hope that all of you are clear with this particular solution. In case if you have any doubts, so you can ask your doubts in the comment. If you understood this problem clearly, so make sure to write understood or +1 or clear in the chat. Thank you for watching this video, and keep coding, guys.